So in this class also some more examples we will see related to general divide and conquer. For example, T of n is T of n by 5 plus T of 4n by 5 plus n. Small values, assume that it is constant. Okay. Then what is the order of growth of T of n? Is it possible to apply master theorem here? Is it possible to apply master theorem here or not? N by 5 less than or equal to 4n by 5. This is true now. So that means whatever functions we are considering all are monotonically increasing. So T of n by 5 will be less than or equal to T of 4n by 5. Now whatever is given here, let us replace n by 5 with T of 4n by 5. T of n by 5 with T of 4n by 5. Then what is that we get? T of n is T of n by 5. I am going to replace with 4n by 5, T of 4n by 5, plus already T of 4n by 5 is there, 4n by 5 plus n. Plus, is this correct? Is this correct? Is this correct? T of n by 5
less than or equal to no, sir.
Oh, less than. Thank you, madam. Thank you very much. Now it is correct. Now it is correct. So that means small simplification. T of n is less than or equal to 2 times T of 4n by 5 plus n. Now which case of master theorem is applicable here? We can solve it by assuming that equals to, then after that we can appropriately change the notation. What is a value? If you compare with the T of n equal to a times T of n by b plus f of n, compare with these and tell me what are the a values. A is 2, b is 5 by 4. Is that correct? And f of n is n. F of n is n. So now which case of master theorem is applicable here? Which case of master theorem? Which case of master theorem is applicable? One side f of n, one side n power log a base b. F of n is n. N power log a base b, n power log 5 by 4 base 2. N power log 5 by 4 base 2. So out of this, which has higher order of growth? This is same as n power 5 by 4 means how much? 1.25 base 2. What is this value?
Log
n
2
power
base 5 by 4 no, sir.
Brother?
Log a base b no, sir. Log 2 base 5 by 4.
Oh, okay, correct. A and B I interchange. Correct.
This will only have more, sir, than n order of growth.
Okay. Let us do it again. A and B we have. What is A value? A is 2, B is 5 by 4. So n power log 2 base 1.25. Is that correct? So it is n power 1 point something. Why? Because this 2 is more than 1.25. Definitely one value will get. Is this correct? It is greater than 1 point something. Is this correct? 2 is between 1.25 and say 1.25 whole square. Is that correct? That means what is the value of log 2 base 1.5, 1.25? It will be between log 2 base 1.5 will be between
log 1.25 and 2 times log 1.2.
how much? Less than log 2 base 1.5 less than log 1.25 whole square base 1.25. What are these values? This becomes 1. This part is 1 or not? Is it equal to 1 or log a base a? It is 1. This is 2 comes out. Again log a base b, 2 into 1. This is 2. That means this value is between 1 and 2. That means whatever we get here, it is more than 1, but less than 2. Is that correct? Is that correct? Now, which case of master theorem is applicable? Which case of master theorem is applicable?
Case 1, sir.
Which case of master theorem is applicable? Whatever value we get here, it is between greater than 1, this value less than 2. So now tell me which case of master theorem is applicable. Which case of master theorem is applicable? One side is f of n is n. This is n. N means n power 1 only, no? Here it is more than n power. It is 1 point something. It is more than n power 1 or not? Is it more than n power 1 or not? Is it more than n power 1 or not?
One, sir.
Case 2 is not correct.
Sir,
Okay,
case
exact
1, sir.
value. Okay, if someone has calculator or with, can you exactly calculate what is log 2 base 1.5? Actually, it is not necessary to calculate also. Okay, it is between 1 and 2. 1 means it is more than 1. Here I have n power 1. With this knowledge, we should be able to say which is more, which is less. N power log a base b order of growth is more, or f of n's order of growth is more? Which has higher order of growth? Which has higher order of growth? Which has higher order of growth?
Sir, n power log a base b has more order of growth, sir.
More order of growth. Okay. So now which case is applicable?
First case, sir.
Thank you very much, brother. Okay. So f of n can be written as, by case 1 of master theorem, what is t of n? What is t of n? T of n is theta of n power log a base b. That means log 2 base 1.25. Is this correct? But what is that we have here? Less than or equal to. So that means what is that we need to write here? Instead of theta, what is that we need to write here? Big O. Is it clear?
Yes, sir.
Okay. Now, what is the other side? What is that we can substitute? T of n, can we write it as greater than or equal to 2 times T of n by 5 plus n? Is this correct? In place of 4n by 5, we substitute. In place of 4n by 5 also, say we have taken n by 5. Then it becomes greater or not, greater than or equal to, is that correct? Now which case of master theorem is applicable? Here, what is A? A is 2, B is 5, and f of n is n. Which case is applicable? Which case is applicable here? F of n is n.
Third case, sir. Case 3.
N power log a base b is n power log 2 base 5. So 2 is between 1 and 5. Log 5 base 5 is 1. Log 1 base 5 is 0. That means log 2 base 5 value is between 0 and 1. Whatever we get here, it is between 0 and 1. That means 0 point something. Is that correct? Is that correct? Now it is n. Now easily we can say, no, which case is applicable? Case 3. By case 3 of master theorem, what is answer? What is answer? T of n is theta of f of n, that is n. Actually, what is that we need to say? Actually, what is that we need to say? Is it theta or something else? Here we have greater than or equal to. So in place of theta, what is that we need to write? Big omega of n. Here, one bound is, it is saying it is at least n. The other one is saying at most n power 1 point something. Both bounds are not same. Both bounds are not same. Then how to find its order of growth? How to find its order of growth? How to find its order of growth? Now, as usual, draw recursion tree for this. Recursion tree method. Okay, now draw recursion tree. What is the recurrence relation given? T of n is T of n by 5 plus T of 4n by 5 plus n. Is that okay? So this can be written as n here. One side T of n by 5, the other side T of 4n by 5. Is it okay? Now what is T of n? N by 5 plus T of 4n by 5 plus n. Now what is n by 5? T of n by 5. Wherever n is there, n by 5. It becomes T of n by 5 square. It becomes T of 4n by 5 square plus n by 5. Is this correct? Is this correct? Wherever n is there, n by 5. Similarly, what is T of 4n by 5? What is T? Wherever n is there in this equation, n by 5 or 4n by 5. T of 4n by 5, already 5 is there, plus T of 4n by 5 4n by 5, so 1 whole square into n plus 4n by 5. Is that correct? Is that correct? Now, in place of T of n by 5, we substitute this value. In place of T of 4n by 5, we substitute this value. Now, what is that we get? What is that we get? In place of, okay, what is T of n value now? What is T of n by 5 value? T of n by 5 is n by 5 plus T of n by 5 square plus T of 4n by 5 square. Is that okay? Similarly, here, what is this value? 4n by 5 plus t of 4n by 5 square plus t of 4 by 5 whole square into n. Is that correct? Is that correct? Keep expanding like this. Keep expanding like this. Whatever tree we get, is it finally last, say, t of 1, t of 1 like this? Whatever tree we get here, is it a complete binary tree? Is it a complete binary tree or not? Is it binary tree or not? Is it a binary tree or not? Any node we take, how many children it has got? How many children it has got? Any internal node you take, how many children it has got?
2 children, sir.
2 children. That means, is it a binary tree or not?
Yes, it's a binary tree.
It's a binary. Is it complete binary tree? Is it complete binary tree?
It need not be, sir.
It's
No.
not.
No, first of all, it will explore from the left side, sir.
Uh,
Then it will come towards the right side.
that means, is it a complete binary? When do we say that it's a complete binary tree?
When the right side children are there, then if you have the more, then it will come to the left side. So it's a complete binary tree, sir.
No, not like that. So complete binary tree means at the ith level, by assuming root at level 0, ith level 2 power I nodes should be there.
Yes.
Ith level 2 power I. Here, 0th level, how many 2 power 0 nodes are there or not?
Yes.
1 node, correct. This
Yes.
is first level. How many nodes are there? 2, correct. This is second level. How many nodes are there? 2 square, correct.
Yes.
Now, next to third level, okay, the level
8
3, 8 will be there. That is correct. But like this, for last level also, it will be like that. What is height of this tree, first of all? What is its height? What is its height?
Log n.
Exactly. So it is n by 5 square. Next it becomes n by 5 cubed, n by 5 power 4, and so on. It comes like this. So first to n by 5.
Yes, till it becomes
n
0.
by 5 square, and so on. At some point of time, n by 5 power I.
Yes.
So in order to get t of 1, we should make n by 5 power I is 1. That implies I is log n base 5. So
Yes.
one side of this recursion tree, what happens is, what happens after log n base 5, it stops.
Yes.
One number log n base 5, it stops or not?
Yes.
What about the other side? Here it is t of 4 by 5 whole square into n, t of 4 by 5 whole cubed into n, t of 4 by 5 whole power 4 into n, and so on. So that is 4n by 5, 4 by 5, 4 by 5 whole square into n. Next, 4 by 5 whole cubed into n, and so on. It goes like this.
Yes.
After I steps, it will be 4 by 5 whole power I into n.
I into n.
But this value should become
1.
1.
Yes.
Is that okay? This same value we can write it as n by 5 by 4 into I. Is this correct?
Yes.
So that means 5 by 4 into I should be same as n. Then this entire value becomes 1. That means what is I? Log n base 5 by 4.
Yes.
So that means one side height is log n base 5 by 4.
Yes.
Log n base 5 by 4. Out of these two, which log n base 5 is more or log n base 5 by 4 is more?
The left side is smaller.
Smaller means more value means it is log n base 5 by 4 value is high, no? That means what? This side, it goes down. That means this is going to be the height, no?
Yes.
And after this, it stops. This after remaining part also, this tree will, some nodes will be there.
Yes.
After log n base 5 level, there are no nodes on left side. But
Yes.
right side still some nodes will be there.
Yes.
Whether this condition will be satisfied after log n base 5 level, ith level 2 power I nodes condition is satisfied or not after log n base 5 level?
Not satisfied, sir.
Not satisfied.
No.
Not satisfied.
Yes.
Okay, correct. That means is it complete binary tree?
No.
Is it complete binary tree? No. Now what is height of this tree? What is height of this tree? What is its height finally?
Log n to the base 5 by 4.
Height is log n base 5 by 4. Log n base 5 by 4. Okay. Now up to log n in this tree, up to log n base 5 level. This is say log n base 5 level. Level number log n base 5. This is level 0. Level 0. Okay. Now first at least this is like complete binary tree. No, up to this part it looks like it is almost complete only. No.
Yes.
It is complete. Now each level, what is the amount of work we are doing? 0th level n. First level, how much we are doing? N by 5 plus 4n by 5. N by 5 plus 4n by 5. Again it is n 5n by 5, which is same as n.
Yes. At every level we are doing n.
Here also, if we calculate this, also will get n.
N.
That means each level, what is the amount of work we are doing?
N operation.
Like that. Here it is n. Here it is n. Even here also it is n. That means how many levels we are doing exactly n amount of work?
Log n to the base 5 times.
Plus 1. Level 0 also we need to add, no?
Yes.
0 to log n base 5 means log n base 5 plus 1, no? So
yes.
1 plus log n base 5 levels, this many levels, each level n work. That means total work up to this. Total work up to this is work up is n log n, can we say? N log n base 5.
Okay.
Even after that also we will be doing some amount of work. How much work we do? This we can write it as less than n. This is less than n. This is less than n. Is that okay? So that means log n base 5 plus 1 level 2, log n base 5 plus 1 level 2, last level how much work? Less than n work.
Yes.
So that means what is the total work we do in this recursion tree? We can say not more than 1 plus log n base 5 by 4 into log n.
Yes.
Into, sorry, not log n, n.
N only.
N. So it is less than or equal to n log n, order of growth.
Yes.
So up to this, what is the amount of work we are doing? N log n.
Yes.
Up to this. So now you tell me what is its order of growth? Up to some level, n log n amount of work we are doing, no? So what is total order of growth of this?
N log n.
N log n. So therefore, order of growth is
N log n.
total work is n log n. Okay, base doesn't matter, no? So therefore, T of n is theta of n log n.
Yes.
This is very much better bound when compared with the previous two bounds which we got now using master theorem.
Yes.
Okay, T of n is theta of n log n. Now, based on this, can we generalize like, okay, if it is of the form n by 2, n by 3, n by 4 plus n, something like that, can we say that its order of growth is always n log n? Okay, we'll see with an example.
No doubt, sir. Here. Sir, Why we are getting here less than an amount of work done, sir, from log n by 5 to downwards?
Because no nodes will be there on the left side now, brother. Here, this n by 5 square 5 cube like this, after log n by base 5 level, after log n base 5 level, no nodes will be there, no? It becomes t of 1 here. Here itself it becomes t of 1. But here it becomes t of 1. That means up to this point, okay. But here, all these levels, the amount of work is strictly less than n, no? Is that okay? Is that okay, brother? This contribution will not be there, no?
Yes.
Except we don't have any nodes.
Nodes. That's why that much amount is reduced. No, that's why we are saying if the amount of work is less than n. Less than n. Is that okay?
Work done we will get up to that level. We know exactly, no, sir. Approximately we know.
Not exactly approximate. Exactly, we know that up to this level, up to here, the amount of work done, this top part itself is n log n. After that also we are doing some amount of work. That is also definitely only here base is 5. If you calculate up to last, it will be less than or equal to n log n base 5 by 4. Is that okay?
Down we can only say the upper bound.
Both we can say, no, brother. See, up if you calculate up to this, you can say only big O bound. Is that okay? I have, is this correct or not? N log n base 5 by 4, is that correct or not?
Correct, sir. But I am
based on this, we can say that T of n is big O of n, big O of n log n. Based on this, can you say this? Is that correct?
Sir, correct.
Is that correct or not?
Sir, this is correct.
Now, here we know that the amount of work done, definitely in T of n, amount of work done is greater than or equal to 1 plus log n base 5 into n. Is that correct? That means here also T of n, we can say it as order of growth is n log n, but base is different. So T of n can be written as big omega of n log n. Now it is big O of n log n. Here it is big omega of n log n. Combiningly, we can say that it is n log n. No? Is that okay, brother?
T of n greater than or equal to, why did we take, sir? Taking that our condition we have written before.
What's your doubt? Could you please repeat?
Yeah, T of n greater than or equal to, how did you take, sir?
One second. Okay, let us take some new slide. This is T of n. T of n is T of n by 5 plus T of 4n by 5 plus n, brother. Okay. Now, this is n. This is okay. Let me write those steps. Up to this, is it clear, brother? Same thing, whatever we discussed earlier. Now, what I'm saying is here n is there, n by 5. So when do we stop? When T of 1 we stop now, we assume that T of 1 is theta of 1. Is that correct? Is that correct? Is that correct? So now we keep doing like this. Next to what will happen? N by 5 keep. Next to T of N by 5 by 5 over 4. T will go and like this will get. Keep doing like this. After some time it will be T of N by 5 over I. Is that okay? Is that correct? Okay. So if N by 5 power I equal to 1, that means I is log N base 5, no? At I equal to log N base 5, what is this value? It becomes T of 1 or not? That means
Yes, sir.
we stop. That means up from here to here, how many levels are there? You please tell me. From here to here, how many levels are there? Last level is log N base 5. First level is level 0, no? How many levels are there?
Log n base.
How many levels are there?
1 plus log n base 5, sir.
Thank you very much here. 1 plus log N base 5. Is that okay? Now let us calculate. At each level, amount of work at each level. Amount of work at each level. At each level. How much is the amount of work done here? N. What is the amount of work done here? N by 5 plus 4N by 5. Is that correct?
N.
Is that correct? Similarly, if you expand here, what is that we will get? N by 5 square plus 4N by 5 square plus 4N by 5 square plus 4 by 5 whole square into N. What is this value? What is this value? It is same as 25 is LCM. We'll get 1 plus 4N plus 4N plus 16N now.
25N by 25.
Is it same as N?
Sir.
Is that correct, brother?
Sir, correct. Sir, correct.
Is that correct?
Yes, sir. It is correct.
Similarly, if you keep calculating like this up to this level, you will get amount of work done is N. Understand? That means each level we do the amount of work we are doing here is N. So now total how many levels are there up to this? You calculate sum here, sum of the work done up to this level itself. What is how much, brother? Sum of the work. How much is this? Can be
N times
sigma I equal to 0 to level equal to 0 to log N base 5. N. Is that correct? Level 0 to level log N base 5, N amount of work. This can be written as N into sigma L equal to 0 to log N base 5. 1. What is this value, brother? N into 1 plus log N base 5. Is that correct? So it is N plus N log N base 5. Up to this itself, the amount of work done is N plus N log N base 5. Is that okay? Based on this, can we easily say that total amount of work done in this entire recursion tree is greater than or equal to N log N? Is this correct? This is order of growth I'm talking about. Is that correct?
Yes, sir.
Is it clear?
Yes, sir. Now it is clear, sir.
I think other part, do you want me to explain?
No, sir. I understood the
Okay, after that, what happens here? This can be written as 4n by 5. First we had, say, here only I write instead of taking use it. First we had T of, okay, let me check with one side every time with T of n we started. Okay, only this side I'll explain. T of 4n by 5. Next, the same thing we can write that T of n by 5 by 4. Is that okay? Next it becomes T of n by 5 by 4 whole square. Next it becomes T of n by 5 by 4 whole cube. Next it becomes T of n by 5 by 4 whole power 4, and so on. After some time it becomes T of n by 5 by 4 whole power log n base 5. After some time it becomes T of n by 5 by 4 log n base 5 plus 1, and so on. After some time it becomes T of n by 5 by 4 whole power I. When this value is 1, we stop. Is that okay? Is that okay? Is that okay, brother? Is it clear? Whatever I have written?
Yes, sir. When I is log n base 5 by 4, then it will become 1.
So that means from here to here, if we take height, how much we get? How much we get?
Log n base 5 by 4 plus 1.
Thank you very much. Here, log n base 5 by 4 plus 1. No, height is only log n base 5 by 4. No, total number of levels is 5 by 4 plus 1. Height is this much only. No, is that okay? Correct only. No, this is level 0 to level. Total number of levels. Total number of levels. Total number of levels is
1 plus log n.
1 plus log n base 5 by 4 is the 2. Now we have one side it stops. One side it stops when the height is log n base 5. Other side it stops when the height is log n base 5 by 4. Out of log n base 5 and log n base 5 by 4, out of this which is small?
Base 5 is small, sir.
So that means it stops. Log n base 5 is smaller than log n base 5 and by 5 by 4. So here itself we will get T of 1, no, in this expansion. Is that okay? But here this side we will get T of 1 here, no? Is that okay? Is that correct?
It is correct.
Is that correct, brother?
Sir, it is correct.
Up to this, what is the amount of work we have done? We know that up to this part, the amount of work done is n log n plus
Greater than or equal to n log n.
exactly n log n base 5 plus n, no, up to this. Is that okay? Now this is level number log n base 5 plus 1. What is the amount of work here done? This side nothing is there, no nodes here. That much contribution will get less, no, become less, no. So that's why the amount of work done at this level, can we consider it as less than n? Similarly, next level less than n, next level less than n, and so on, last level less than n. Is that okay? Is that okay? So now we add for all levels. So therefore, what is T of n? Sigma level number is 0 to log n base 5 by 4 less than n. Can you say this? Generalizing here n, but here less than n. By generalizing this, we can say less than n. That means the amount of work is strictly less than this. Is that correct? Is that correct? If you simplify this, what is that we get? 1 plus log n base 5 by 4 into n. So which is n plus n log n base 5 by 4. But here it is less than, T of n is less than this much. Based on this, what is that we can say? T of n is big O of n log n. Based on this, what is that we can say? T of n is
big omega of n log n.
Combining these two. Combining the two, what is that we can say? T of n is theta of n log n. Is that correct, brother? Is there any doubt?
Now it got clarified.
What, brother?
Now got clarified, sir.
Okay. Thank you, brother. Thank you.
Thank you, sir.
Okay. Now say T of n is, we have something like this. T of n by 2 plus T of n by 4 plus T of n by 8 plus n. What can you say about order of growth of T of n? What can you say about order of growth of T of n? Based on previous method, can we say that it is also n log n? Can we say that? Okay, someone has given answer also. It is theta of n log n. So T of n is theta of n log n. Now I'll show that this is wrong. This is wrong. Simply because here, what was our argument? What was our argument earlier also? What was our argument?
Sir, can we say that it is n power log 3 base 2? Not more than that.
Okay. So that also we'll try, sir. My main intention is to show that it is not n log n. Okay, no, it's not n log n. Okay. One way is we n by 2, is it less than, okay, n by 8, is it less than n by 4? Is this correct? Correct, no? Hence, T of n by 8, is this correct? Now, whatever equation 1 is given, everything will replace with, say, 2. We write in terms of T of n by 4, I'll replace with T of n by 2. T of n by 8 also we replace with T of n by 2. Then what is that we get?
Yeah, 3Tn by 2 plus 1.
T of n is less than or equal to T of n by 2 plus T of n by 2 plus T of n by 2 plus n. Is that okay? So that is T of n is less than or equal to 3 times T of n by 2 plus n. So this already we solved in next class also. This we can write it as big O of n power log 3 base 2. This is approximately n power 1.585. Is that okay? Which case of Mahta theorem? Case 1. Is that correct? What is the other way of doing this? Same thing. Can we say that T of n is greater than or equal to 3 times T of n by 8 plus n? Can we say that T of n is greater than or equal to 3 times T of n by 8? That means n by 2 I replace with n by 8, n by 4 also replace with n by 8, n by 8, okay, n by 8 as it is. Is this correct? Another way? Is that correct? Is it clear or do you want? Okay, I'll elaborate. T of n is greater than or equal to T of n by 8. In place of n by 2, I have written n by 8. N by 4 also n by 8. N by 8 already n by 8. Plus n. Is this correct? Why? Because n by 8 is smaller than n by 4. It is even smaller than n by 2. So that's why if I replace all with n by 8, then I should put at least this much. No, that's why T of n is greater than or equal to 3 times T of n by 8 plus n. Now, which case of master theorem is applicable? Case 3. Directly, case 3 of master theorem, we can say that T of n is big omega of n. Is that okay? Now we have two answers. Are these two matching? Matching means are these two same? Always we need theta bound. Based on these two, is it possible to give some theta bound?
Not possible, sir.
Not possible, no? It's not possible. Why? Because both are same means then we can say something. But here it's not possible. Here say it is n. What is that there? It is saying it can be greater than or equal to n. That means here we have n. N. Here it is saying less than or equal to n power 1.585. This is n power 1. That means our answer may be anything from here to here. We don't know exactly what is the answer. It is like saying cost of the book is greater than or equal to 500. Saying cost of the book is less than or equal to 1600. Both are correct. This is correct. This is correct. Now, many options are there. It can be 500 or 501 or 600 or 800 or 1000, 1500 or 1600 also. Exact order of growth we don't know. That means exact cost of the book we don't know. Then how to do it? How to do it? Again, we'll go for recursion tree. So T of n so this can be written as n T of n by 2, T of n by 4, T of n by 8. Is that correct? Now, what is that we can write in place of T of n? N by 2. What is that we can write in place of T of n by 2? Wherever n is there, n by 2. What is that we can write? T of n by 2 by 2, n by 2 by 4, n by 2 by 8, plus n by 2. That means T of n by 2 we can replace with this now. So n by 2 one side, T of n by 2, okay, 4. Other side, T of n by 8. Other side, T of n by 16. Is that correct? Similarly, what is T of n by 4? What is T of n by 4? T of n by 4 by 2, T of n by 4 by 4, T of n by 4 by 8 plus n. Is that okay? So it is T of n by 8, T of n by 16, T of n by 32 plus n. So now in place of T of n by 4, this thing we can replace, no? In place of T of n by 4, what is that we can write? T of n by 8, T of n by 16, T of n by 32. Similarly, in place of T of n by 8, what is that we can write? Wherever n is there, n by 8. What is T of n by 8? T of n by 8 by 2, T of n by 8 by 4, T of n by 8 by 8 plus n by 8. Is that okay? Now, what is that we can write in place of T of n by 8? What is that we can write in place of T of n by 8? All are same level. Okay. What is that we can write in place of T of n by 8? T of n by 8 by 2 means T of n by 16. T of n by 8 by 4 means T of n by 32. T of n by 8 means T of n by 64. Is that correct? Is that correct? Is that correct or not? Now, what is the amount of work done at level 0? N. What is the amount of work done at level 1? N by 2 plus n by 4 plus n by 8. This is 7n by 8. That means it is strictly less than n. Is that correct? Is that correct? Here, if you calculate, after expanding, if you calculate this, you will get 7 by 8 whole square into n, which is less than n. Next level, if you expand 7 by 8 whole cubed into n, which is less than n. Next level, 7 by 8 whole power 4 into n, which is less than n, and so on. What is the height of this recursion tree? What is the height? What is the height? Can you please tell me what is height? What is the height? What is the height of this tree? One side it stops.
Log n base 8, sir.
One is log n base 8. Thank you very much. Here. Okay, log n base 8. This side, middle, what is the height? From here to here, what is this value? Log n base. Is that correct? Now this side, what is the value? From here to here. Log n base 2. Is that correct? Now what is height of this tree, recursion tree? What is height of recursion tree?
Log n base 2.
If T is recursion tree, what is its height? Height is log n base 2. Now, what is the total amount of work done here? What is the total amount of work done here? What is the total amount of work done? T of n can be written as sigma level 0 to log n base 2. What is the amount of work? 7 by 8 whole power level into n. Is that correct? Is that correct? Is that correct? Okay, in fact, because after some level, no, this even gets reduced further. That's why I can put even less than or equal. Is that correct? Is that correct?
Okay, less than or equal to.
Yes, madam. Now, can we say that it is less than or equal to n? I will take it outside. It is independent line, not based on the level 0 to log n base 2, 7 by 8 whole power level. Is this correct? Is that correct? Can we say that this is strictly less than sigma level equal to 0 to infinite, 7 by 8 whole power level? Is that correct? Because there are only log n base 2 levels, but I am taking up to infinite levels. Is that correct? What is this entire value? It is of the form 7 by
Why are you taking
Whole power
by infinity, sir?
brother.
Sir, why are you taking to infinity, sir?
Okay. If only thing is, I'll tell you only simplification. This is only simplification. Level number I won't put. J equal to 0 to. Do you agree with this? See, finally, what is we are trying to find this value, brother. That's all, no? What is this? If we expand, okay, let me take new sheet. What is that value? We are trying to simplify this level equals to 0
Level
to
0 to
log n base 2
7 by
7 by
8.
8 whole power level. No?
Yes.
What is this value? 7 by 8 whole power 0 when level is 0. When level is 1. When level is 2. Is that correct? When level is log n base 2. Is that correct?
Yes.
Can we say that it is less than 7 by 8 whole power 0 plus 7 by 8 whole power 1 plus 7 by 8 whole square plus and so on plus 7 by 8 whole power infinite? Is that correct? Is that correct? It is simply, you forget about level number, all those things. It is some summation expression. Summation expression. You forget about recursion tree. This is some summation expression that I have written equivalent expression like this, but I know that right hand side is strictly higher than this value. No, is that correct?
Yes, sir.
Okay. Now is it infinite GP? Sum of terms in infinite, is it a geometric progression? Whole power 0, 7 by 8, whole power 1. What is formula for infinite terms in GP? A by 1 minus
1 minus r.
What is A here? 7 by 8 whole
1.
power 0. What is 1 minus R? 1 by 7 by 8. This is 1 by 8 minus 7 by 8. It is 8. Is that correct? Is that correct?
8.
That means this entire value is a constant. This entire value is constant. So now go back to previous slide. That means now I know that this entire value is a constant. Now what is that finally I have got? T
N.
of n is less than
N.
n into some constant.
N. Finally,
Based
we
on
get
this,
N.
what is that we can write? Based on that, what is that we can write? T of n is
N. Less
Big
than
O
N.
of n.
big O of n. Is this correct,
Yes.
brother? Is that correct? Simply by seeing this recurrence relation, can we say that T of n is big omega of n? Why? Because n is there, no, in this expression. Without doing anything, can we say that T of n is big omega of n?
Yes, sir.
By
That is the
combining,
maximum term.
n is there in this expression. That's all. I am not even going into other details. Simply
Yes.
n is there. Definitely, its order of growth will be n or even more than n. Definitely, it cannot be less than n. No, already n is there.
Yes.
Okay, so that's why T of n is order of growth is omega of n. Now you combine these two. T of n is big O of n. T of n is big omega of n.
Omega of N.
From these two, what is that we can write?
Of N
T
equal
of
to
n is
theta
theta
of
of n.
N.
Unlike previous case where n by 3, 2n by 3 plus n, we got n log n. But here it is only theta of n only. Is the difference clear? Why did we get theta of n only? Why not n log n? What is the difference? What is the difference?
From starting only, it is decreasing, sir. Less than
That is, in
amount
the
of n's.
other
But-
examples, we had every time exactly n like this. But here we have strictly less than n, no?
By 8
When we
and
have
by
taken
8
a
It is
summation,
decreasing.
it has, because this other
Decrease.
terms, their value has become some constant
Decreasing.
to n, hence it is n. That is the main difference. If it was exactly n, then we would have got n log n. We have got n log n. Okay. For example, if recurrence relation is given like this, T of n is T of n by 2 plus T of n by 4, T of n by 8 plus T of n by 16 plus n. What's the answer? At least 2 steps you expand automatically you'll get idea clue. Example 1, are you able to do at least for 2 steps?
Sir, this is similar like before question, sir.
Yes, brother. Yes.
Question only.
So what's the
Same,
answer?
sir.
Same. The answer is n log n or n?
N, sir. Theta of n.
Theta of n.
N only. In this case,
This is also same, sir.
this is also theta of n. Here I don't even write. You please check. Okay.